In this lecture, we talk about MEDSORT algorithm, which is again a divide and conquer type of algorithm. The working process of this algorithm is first it divides the given array into smaller subarrays by progressively dividing each subarray into two halves. So this process recursively continues until they go down. Each subarray is reduced to at the most single element. Once it is reduced into smaller and smaller subarrays, where each subarray consisting of single element, in the next phase it conquers them and it sorts them into sorted arrays step by step, again recursively, until the entire array is built back in a sorted form. This is how, in a nutshell, the working process of MEDSORT algorithm. This algorithm can be implemented in several ways. Here we are talking about recursive type of algorithm, divide and conquer type of algorithm, and it has with two phases. One is division phase and another is merging phase. This has another variant where division is not done but non-recursively, but every time considering a pair of elements, also by progressively merging them we can implement in another way. But here we are talking about MEDSORT algorithm in a recursive way, where we divide the array into smaller subarrays each time until each subarray consisting of one element, and then merge back. This is the process that we are following in this lecture. Now, this algorithm is much better when compared with others if the array is of larger size and the time complexity is also very good, efficient. But of course, it requires additional space because we need to divide into smaller and smaller subarrays, and we need to remember them until it is being merged. And it is a stable algorithm. The stability can be defined in terms of given array consisting of elements where some of the elements are of same value, then in the sorting process, if they do not change their order, then we call them as a stable algorithm. This algorithm is also a stable algorithm in this respect. Now, straight away, let us go into an example consisting of 7 elements here: 24, 6, 18, 10, 45, 98, and 58. So in the first step, we divide the array into two smaller subarrays consisting of 24, 6, 18, and 10, and 45, 98, and 58 into another one. Again, progressively, the first subarray is divided into two parts: 24, 6, 18, 10. 24, 6 is again divided into 24 and 6. Likewise, 18, 10 is divided into 18, 10 subarray. 45, 19 is divided into 45 and 19, 98, and 58 is a single cell. So at this stage, there are 7 subarrays where each subarray consisting of a single element. By this time, the division process is completed, where every time the array is subdivided into smaller and smaller subarrays. Now at this stage, so there is no further division. Now we will go for the merge process. So in the first merge process, 24 and 6 are two subarrays. We need to merge them. In this process, we will compare the elements 24 and 6 being smaller, into the subarray consisting of two elements. First we copy the least element among the two, 6, into the first place, and then 24 into the second place, so that a new subarray is created by combining two smaller subarrays, 24 and 6. So 6 and 24 is a new subarray after merging the two subarrays. Like this, 18 and 10, again two smaller subarrays. By merging them, the least element 10 is copied into the first position of the merged array, and 18 is copied into the second one. Like this, 45 and 98 are merged. 58 is a single one, so nothing to be done there. So after first merging, we have 4 small subarrays consisting of 2 elements each, and the last one is a single element. In the second cycle of merging, the two smaller subarrays 624, 10, 18 are being merged. Again, we create a smaller subarray consisting of 4 elements, and the least among the first two elements, 6 and 10. 6 and 10 are compared. 6 is least, so copy 6 into the first location of the new merged subarray. And then of the remaining elements, 24 and 10 are the two elements. Again, compare 24 and 10, 10 being the least, copy 10 into the second location of the new merged subarray. And of the remaining elements, 24 and 18, 18 being the smaller, copy 18 into the third location of the merged subarray. And of the remaining elements, 24, just copy 24 into the fourth location. Again, for merging 48, 45, 98 and 58, compare the first two elements 45 and 58, 45 being the least, 45 is copied into the first location. Of the remaining elements 98 and 58, 58 being the least, 58 is copied into the second location, and then 98 is copied into the third location. So like this merged, the subarrays are merged, new subarrays are created. Again, these two subarrays are merged again into a new subarray consisting of 7 elements. Again, the first positions are compared, 6 and 45, 6 is the least, copy 6. Of the remaining 10 and 45, 10 is the least, copy 10. Of the remaining 18, 45, 18 being the least, copy 18. 24 and 45, 24 being the least, copy 24. Once this is done, the subarray is exhausted, just copy the remaining elements of the second subarray, 45, 58, 98 straight away into the subarray. So once this is done, the entire array is merged into the assorted form. So this is how the algorithm progresses. Sort algorithm takes array as an input. The first step is it checks the length of the array. If length of the array is less than or equal to 1, nothing to be done, just return the array, nothing to be sorted. Otherwise, it calculates the mid. Length of the array is divided into 2. Integer part is of course used here. And on the left subarray, again merge sort is applied on the left subarray. So it's a recursive type of algorithm. So based on the mid value, on the left subarray, the recursive merge sort algorithm is applied. And after that, right is again merge sort as applied on the second half of the array. So progressively it applies the merge sort on the left subarray and the right subarray. Each time it is divided into smaller and smaller subarrays. And once this division is complete, then merge has to take place. So merged is another routine which merges the left and right subarrays, because each left and right consists of subarrays at every location. So merge is performed on the left and right subarrays, and they will be merged progressively. Once the merging process is done, then return merged. So recursively this is being done until the entire array is sorted. If you look into the merge part, so how the subarrays are merged. So left and right are the subarrays which are given as an input to the merge process, and result is we initiate 3 variables here. Result, which is an empty array to start with, which is equal to the size of the given array, and 2 indices are there, I and j, which are equal to 0. So these indices are used to compare the subarrays, while I is less than the length of the left subarray and j is less than the length of the right subarray. Both are compared every time. If the left of I is less than or equal to the right of j, that means it compares the least elements among the 2 left and right subarrays, which are obviously the leftmost elements of each of the subarrays. It compares them. If left of I is less than, that means the element that is present in the left subarray is smaller than the first element of the right subarray, then that element is copied into the merged subarray. So add left of I to the result, the new subarray, and then increment I. Or otherwise, if right, that means here if it is left is less than or equal to right, then we are comparing here. So the other one is left is greater than right. So else, in the else case, if left is greater than right, then simply copy the right of j into the result and increment j. So either we copy the element from the left subarray or we copy the element from the right subarray. If both are equal, obviously we'll copy from the left. That's how the process goes on. Once this is done, while I is length of left and length of right, j length of right, sometimes what happens is if the length of one of the subarrays is larger than the length of the second subarray, one of the subarrays may exhaust before the other. If one of the subarrays exhausts in this comparison, the remaining part of the subarray, which is left, is to be copied as it is because already it is in the sorted form. So while I is less than length of left, add left of I to the result, increment I, or while j is less than length of right, add right of j to the result, increment j. So that remaining part is copied as it is into the result. So this is how we merge the subarrays. This process goes on until the merging process goes on until the smaller subarrays are merged back until the length of the total array is done. So this is how the merge sort algorithm runs. Let us try to apply the algorithm here. Given array is consisting of 7 elements, mid is calculated. In this case, mid is taken as 4. After four elements, first subarray is divided 24, 6, 18, 10, and 45, 58, and 98 and 58 is the second subarray, consisting of 3 elements. Once mid is calculated, the merge sort on the left subarray is initiated, which is 24, 6, 18, 10. Again, for this, the algorithm goes back and calculates the mid. Again, it is divided into smaller subarrays. Again, the merge sort on the left subarray of 24, 6 is initiated, and it is divided into 24 and 6. Again, the merge sort on 24 is initiated. It being single element, it returns back the 24. Then the right part of 24 is not there, so it is closed. Merge part is also not there for 24. For 6, which is the right part, then goes back to the 24 and 6. The right subarray, merge sort of right subarray is 6. Again, it consisting of single element, it returns back, so there is no left and right for this. So by that time, the left part and right part, merge sort and left part and right part of the 24, 6 subarray is complete. And then the control goes to the merge of the two 24 and 6 subarrays. So merging is done for 24 and 6. 6 being the least, 6 is copied into the new array. Next is 24 copied into the second location of the subarray. So this merge part of 24, 6 is complete. Thereby completes the left part of left subarray, merge sort on the left subarray of 24 and 6, 18, 10. Then the control goes to the right subarray, merge sort on the right subarray 18, 10. So again, merge sort of left subarray 18, merge sort on 8, merge sort on 10. They being single elements, it returns back. Then again, the right part is not there because single elements are there. Then the merge process again continues for 18, 10. They are merged to 10 and 18. So by this time, the merge of all the 4 elements are complete, which completes the left subarray of the given total array. Then the control goes to the right part, the merge sort of the right part. So like this, the algorithm continues of merge sort on the left part, merge sort on the right part, and merge. Right? This is how the algorithm progresses until the entire subarray is merged back. When it comes to the best case, if the given array is already in the sorted form, the difference comes only in the merging process, because the left elements are already in the sorted form. They will be compared with the rightmost element. Once the left part is completed, simply we copy the right part into the subarray because they are already in the sorted form. In all the 3 cases, this is the only place where the difference comes. Otherwise, the remaining part is same for all the 3, because dividing and merging them is required at every subarray. In the worst case, if the arrays are in the reverse order, where they are in decreasing order, then every time we have to compare them and we have to place them in the right place. So in the merging phase, in the worst case, if the array is in the reverse order, it takes much time when compared with the best case. Of course, in the average case, if some of the elements are in the sorted order and some of the elements are in the unsorted order, reverse order, then it becomes the average case. But more or less, all the three cases will have similar, more or less similar type of time complexity for smaller subarrays. For larger subarrays, a marginal difference may occur.